Okay. Thank you everyone for participating in my talk. My name is Junwei. So today I would like to share my study with you. My research topic is a usability study of cryptographic API designs. So here's the outline of my talk, and I will start by introducing the backgrounds and followed by the problem statement and methodologies. Then I will present my study results. And at the end of my talk, several recommendations will be given to mitigate the common pitfalls based on our findings. So nowadays, we live in a world where everything is connecting using internet. Many services such as banking and shopping can be done online. And this is all thanks to the development of cryptography that enables secure communications between clients and servers. Without it, we would not have such convenience. While cryptography has become standards for secure applications for over a decade, cyber attacks that target online services have grown significantly. Attacks such as phishing, malwares put users' privacy at risk. And apart from the attack, many online services did not handle security properly, which opens the opportunity for malicious party to exploit the system and steal sensitive information. As the result, service providers suffer from financial loss and the loss of confidence in their customers. And several literatures pointed out that many of the cyber incidents could have been prevented in many different ways, as many study points out that many developers struggle to deploy cryptography to their software product correctly, which results in a series of security issues that could lead to cyber incidents. And such issue is commonly referred to as cryptographic misuse. Cryptographic misuse refers to the use of incorrect cryptographic components. Types of misuse include weak ciphers and modes, incorrectly generating parameters such as keys, initialization vectors, and nonce. According to a study, the team surveys over 11,000 Android applications that use cryptography in their code and found that over 88% of them contain at least one cryptographic misuse. Crypto misuse such as DES allows brute force attacks to execute, which completely defeat the security and reveal sensitive information. These literature suggests that most of the misuse could have been prevented if the API was designed more user-friendly. And as a developer, it is crucial to utilize different APIs provided by the libraries to achieve a specific task. But the reality is that many crypto libraries are too complicated for non-cryptographic experts to use it properly. So research have come up with solutions that mitigate the problems, and attempts have been made to mitigate the issues from different aspects, such as reducing the complexity of API calls and parameters, and improving the readability of the documents, and so on. However, none of these improvements denotes the real cause of the issues, which is what hinders the usability and causes the misuse to begin with. Therefore, we conduct a usability study on 6 different cryptographic libraries to evaluate the usabilities. We analyze the usability of symmetric encryption APIs provided by the libraries to find out what designs results in potential issues. To do that, we employ a case studies where a developer wants to encrypt some data. The developer will need to generate a key and encrypt the actual data. So, based on this case study, our first task is to generate a symmetric key, and followed by the second task, which is to use the key for encryptions. We use the case study to simulate how developers use cryptography in practice and observe the process for our study. So to complete our survey, we chose the following libraries. For C, we choose OpenSSL. And for Java cryptography architectures, Apache, Common Cryptos, and Tink are chosen. And lastly, for JavaScript, Crypto Node.js and XHCL are chosen. Among 6 libraries, we choose 2 libraries that the developers claim to have improved usabilities. They are Tink in Java and XJCL in JavaScript. We begin to implement the task according to our case study. Then the solutions will be used to evaluate from 4 different aspects, which are API call sequence, error handling, default values, and documentations. These evaluation metrics are chosen as they take up the majority of crypto misuse reported by several literatures. And next I will present our study results. For the first study, we evaluate the results based on 2 measurements, the number of lines of code and parameters. These 2 metrics are usually used for measuring the complexity of a software product, and we deploy them for measuring the complexity of API call sequence. For task 1, which is to generate asymmetric keys, all libraries perform very similarly, as most libraries utilize pseudo-random number generators or key generators for generating a symmetric key. The differences begins with task 2. Libraries with usability claims reduce the complexity by hiding unnecessaries away from the users. As a result, both Xuechao and Tink only require less than 5 lines of code and parameters for encryptions to be done. As for the others, OpenSSL is by far the worst in terms of usability, due to the limitations imposed by the language itself, whereas other libraries such as JCA and Crypto fully take advantage of language-specific features from object-oriented programming to reduce unnecessary function calls, with only one exception being that ACC performs worse than the OpenSSL, due to the fact that a concept of crypto providers is introduced and required to be set up manually, which results in longer parameter lists. Next, we pay our attention to our second study, which is the error handling. Although all libraries have provided a mechanism to detect errors, none of them can meet our requirements. Specifically, we want to learn if the system can detect as many potential threats as it can. Therefore, we evaluate it based on the following criteria: weak ciphers, incorrect key size and parameters, constant parameters such as key and IV. OpenSSL once again scored the lowest, as the building mechanism does not detect any of the potential issues we listed, and followed by the Crypto and Xuechao, as they are capable of detecting whether the key size is incorrect. And JCA and ACC introduces extra checks for parameters to ensure that they are configured correctly. However, none of these libraries can detect parameters with low entropies and weak ciphers. So keys, encryption parameters such as encryption keys and the IV with low entropy enables brute force attacks to be launched, which in some cases a correct key can be found within a reasonable amount of time. And weak ciphers such as DES and RC4 have broken and should not be used. And so next, our first studies focus on the default values. Most of the libraries do not provide a default values. Specifically, users must specify all necessary parameters before the ciphers can be used. We pay our attention to look for default ciphers in the case of AES. And JCA by default supplies an AES with ECB mode if users did not specify exactly what mode of operation to use. As the result, it introduced security issues, as ECB mode is the least secure mode and it should not be used. And on top of that, utilizing default value will increase the complexity of maintenance. Specifically, one must balance between the convenience and the securities, as cryptographic algorithms will eventually be defeated from time to time. And having a default value will introduce breaking changes in the futures, which is not what developers expect. While Xuechao also utilized default value, It uses CCMO, which is much more secure than ECB. However, such default value will inevitably pose security issues in the futures. So lastly, we briefly talk about the documentations of the libraries. As this is subjective to human factor and experience, we are only curious if a library can complete our task relying solely on the documentations that the library provides. Not surprisingly, OpenSSL fails to deliver that, and this is due to the fact that it utilizes designs where only one common interface is shared across different Cypher instances, as opposed to having a dedicated APIs for every Cypher instance. On top of that, the documentation is difficult to navigate, with the example codes hidden in the bottom of a page among other 200 exported function names. And other libraries such as JCA has a single page reference guides where it attempts to denote as many information as they can, with some example codes that help explain the uses of their APIs. And similarly, ACC shared example codes with a Java doc files that details all exported functions. Other libraries such as Crypto, SJCL, and Ting have a well-written documents with example codes that can be used with little to no modifications. So based on the finding that we have, we make a list of recommendations based on our findings. For API call sequence, we suggest that API designers should simplify initializations and the actual encryptions. As many traditional libraries requires two separate function calls to achieve initializations, while libraries with usability claims reduce that to 1 or even 0. This can be done by utilizing functions overloadings, a method to hide complexity for users who are less experienced. And for the second, we recommend that more checks should be added to include a wide variety of crypto errors. On top of that, the error message should deliver helpful information as opposed to generic message that confuse the users. For the default value, it can be used but only to some extent. For instance, we can use it in components that are unlikely to change from time to time, such as key generations. Parameters that are critical to security should not be used, and we suggest that the library designer should use distinct API function names to clearly identify the ciphers, as opposed to having a generic interface like the traditional libraries do. And lastly, for the documentations, it should denote the libraries as detailed as they possibly can, with example codes to help users identify the correct usage in different use cases. So that's the end of my talk, and thank you for your time and patience. And if you have any questions, please feel free to send me an email and discuss that with me. I'm happy to answer any questions that you guys have and any suggestions and improvements as well. All right, thanks again.